All right, final one. This one's a doozy of a word problem, but it's a really great problem. Norman window has the shape of a semicircle on top of a rectangle. If the perimeter of the window is 6 meters in total, what height, h, and width, w, will give a window with maximum area? So at this point, how the heck do we do this, right? So first thing we want to do, we want to understand what's going on. So this seems to make sense, right? We've got a semicircle, right? That's our semicircle right here. What's a semicircle? A semicircle is just half of a circle. And yeah, that looks like half of a circle on top of a rectangle. So it's on top of a rectangle, and we've got our rectangle right here. So that seems to make sense, right? We've got a semicircle on top of a rectangle box. Okay, that idea makes sense. The perimeter of the window is 6 meters. Now, we might have forgotten what perimeter is, but perimeter is just all the outside edge put together. So nice, hard to see yellow. So we go outside perimeter, 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 perimeter. So it's going to be all of the outside of that box, but it is not going to go across now. It's going to also have to be outside perimeter of the top part of the window, right? We've got that dashed line there to indicate that's where we split into the semicircle, but there's no actual material there. It's just the perimeter is the very outside part. So the perimeter will be the top part of that semicircle and then 3 sides of our box. The 4th side doesn't actually exist. It's just connected into the semicircle. All right, so that makes sense. We know that is 6 meters. And then we want to ask what height and width will give a window with maximum area. So if we're looking for area, we're probably going to need to use area, right? So A equals area. We'll define that idea. If we also know information about the perimeter, then we'll say P equals perimeter. Okay, so let's work these things out. So if area is equal to the area of this part plus the area of our box. So it's the area of our semicircle plus the area of our box. So area of our semicircle, well, what's the area of a circle? So circle, area for a circle is equal to pi r squared. So a semicircle, if it's a half circle, that's going to be area equals 1/2 pi r squared, because it's half of the circle, right? So we've got 1/2 pi r squared. Oh, hey, we don't have an r yet, so we better introduce an r. So we'll say, here's the middle. So r is from the middle of our circle out like that. So area equals pi r squared divided by 2, because remember, it's a semicircle, so it's half of it, plus, what's the area of our box? That's height times width, so height times width. Now, we don't really want to have r, right? The fewer variables, the better if we're going to try to solve this. So how does r connect to the rest of it? Well, r, hey, look, that's connected to our w because it's just half of that side, So r equals w over 2. So we can change this formula into area equals pi r squared is w over 2 squared over 2 plus height times width. Now we've managed to get rid of the radius there, so let's simplify that out a bit more. Area equals pi squared, the w over 2, that begets w squared over 4 over 2 plus hw. So we've got this whole thing divided by 2, so area equals pi w squared, and we're dividing, so with the 4 and the 2, since they're both dividing on pi, dividing on that stuff, they're going to combine into divide by 8 plus hw. Great. So we've got area equals pi w squared plus hw. All right. What about perimeter? What can we say about perimeter? Well, the perimeter is going to be equal to, well, there's an h here, there's a w here. What's here? Just another h. And then what is this portion here? So right off the bat, we see we've got 2 h's plus a w plus something else. So circumference for a circle, right? If we want the perimeter of a circle, that's circumference. So circle circumference is equal to 2 pi r. 2 pi r. But if it's a semicircle, then it's half of a circle, so it's going to be 2 pi r divided by 2. So perimeter for a circle will be, perimeter for a semicircle will be 1/2 times 2 pi r, which is just going to be pi times r. So we've got 2h plus w plus the amount of perimeter that our semicircle puts in is pi r. Now once again, we don't really want to have extra variables floating around, so we want to get rid of that. So perimeter equals 2h plus w plus pi times w over 2. Great. So at this point, we see that we've got h and w, we've got area. So if we could turn this into, we've got area is unknown. We don't really know what the maximum area is or what area we're dealing with. Really, it's a function that's going to give area when we plug in h and w, so it's not even something that has a fixed value necessarily. What about perimeter, though? Perimeter, that is something we do know. Remember, perimeter is 6 meters. So we can plug in 6 equals 2h plus w plus pi w over 2. Now it seems like we've got more w's than we've got h's in both area and both our area and perimeter stuff. So let's try to get rid of area. So we'll figure out what we'll figure out what h is in terms of w, so we can substitute out the h and switch it in for stuff about w. So we'll move everything over. We've got 6 minus w minus pi w over 2 equals 2h. We divide by 2 on both sides. We get 3 minus w2 minus pi w over 4 equals h. And now let's just pull those things together so it'll be easier to plug in later into our 1 over here, because we want to swap out the h here for it. So 3 minus 2w over 4 plus pi w. Now that part might be a little confusing, but notice that this has minus and this has minus, so when we combine them together, they're just one minus because they're actually working together before they do their subtraction, equals h. And we can even pull out the w onto the outside, so we get 3 minus 2 plus pi over 4 times w equals h. Great. So now we've got an expression about area, and we've got an expression about h and w. So at this point, we can plug in what we know about h, and we can plug it in for the h in the hw in our area, and we'll have area equals just stuff involving w. And since it's just stuff involving w, we'll have just one variable. Maybe we can figure things out. Maybe it looks like something. Maybe it looks like a quadratic, since after all, this was all about how quadratics work. So student logic seems pretty likely it's going to wind up looking like a quadratic, and we can apply the knowledge that we just learned. So maximum area at what h and w? We've got area equals pi w squared over 8 plus wh, and h equals 3 minus 2 plus pi over 4 times w. Okay, great. So at this point, we take h here, we plug it in over here. So we've got area equals pi w squared over 8, that's still the same thing, plus w times h, so w times, what's h? 3 minus 2 plus pi over 4 times w. We expand that out, and our area is equal to pi w squared over 8 plus w times 3 minus 2 plus pi over 4w, so we get 3w minus, and let's keep it as 2 plus pi over 4, and it just combines with that other w. We've got w squared. Hey, so now we've got a w squared here and a w squared here, so let's make them talk to each other. So we get pi w squared over 8. So let's actually pull that down. So we'll make it as pi over 8 w squared minus 2 plus pi over 4 w squared plus 3w. So now we've got pi over 8, and we can bring this stuff to bear, so it'll be minus 2 plus pi, but it used to be a 4, so it's going to become an 8. We're going to multiply by 2 here to keep it the same. So 2 times 2 plus pi becomes 4 plus 2 pi. So we've got pi minus 4 plus 2 pi, 8 w squared plus 3w. We simplify this out. Pi minus 4, so the negative 4 will come through, and minus 2 pi will become minus pi over 8 w squared plus 3w. Hey, look, if area equals this, then this right here, this whole thing, is a quadratic. So if it's a quadratic, then we can use the stuff that we know about where vertices show up. Where do vertices show up on the parabola? Now we're looking for the maximum area, so we better hope that our parabola points down so it does have a maximum at its vertex. Sure enough, we've got a negative here and a negative here, and since that's on the w squared, that means we could pull out the negative, and our first a is going to be negative quantity 4 plus pi over 8. So that whole thing winds up being a negative number. So sure enough, it is going to have a vertex at the top, so it will have a maximum area out of this. It is cupping down. So at this point, we figure it out. So remember, vertex is at our horizontal location. So in this case, horizontal would be just our W. Vertex is going to be at W equals negative B over 2A. So what is that? So it's going to be W equals, what is our B? That's going to be 3. So we've got negative 3 over, what is A? A is this whole thing. So negative 4 minus pi over 8. So this is a little bit confusing, but we've got a fraction over a fraction. So if it's like this, we can multiply the top and the bottom by 8. So 8 on top, 8 on the bottom, we'll get negative 24. And the 8's down here will just cancel out. So we'll get negative 24 minus 4 minus pi. We see that there's negatives everywhere, so we can cancel out all of our negatives, multiply the top and the bottom by negative 1. We get positive 24 over 4 plus pi. So the maximum is going to happen at 24 over 4 plus pi. There is our, oh, whoop, sorry, one thing, just realized, made one tiny mistake. It's 2a, right? So we've got a 2 here, so it's still a 2 up front, so it's not 4 plus pi. Always important to think about what you're doing. 24 over 2 times 4 plus pi. So that cancels to be 12 over 4 plus pi. Now, that was clearly a very long, very difficult problem, but we see it's actually really similar to the previous example that we just did. All we're looking for is where's the vertex. The only thing that this is it's couched inside of a word problem, so we just have to be carefully thinking, how do we build equations? Once we've got our equations built, how do we put them together? How do we get this to look like something where I can apply what I just learned in this lesson, how I can apply this stuff about quadratic properties. So we find out that the maximum occurs when W is equal to 12 over 4 plus pi. Now they asked, what h and w? So since we have to figure that out, we know h is equal to 3 minus 2 plus pi over 4 times w. So h is going to be at its maximum as well, since it's the h and w. 3 minus 2 plus pi over 4 times 12 over 4 plus pi as our w. So we notice that 4 can knock out the 12 and we'll get 3 up top. So we get h is equal to 3 minus 2 plus pi, so 3 times 2 plus pi over 4 plus pi. We want to put them over common denominators so we can get the two pieces talking to each other. So we've got 3 times 4 plus pi over 4 plus pi. And then it's going to be minus 3 times 2 plus pi, so minus 6 minus 3 pi. So we've got 12 plus 3 pi minus 6 minus 3 pi all over 4 plus pi. So finally, our h is going to be the minus 3 pi's cancel each other out. 12 minus 6, we get 6 over 4 plus pi. And that's our value for what our maximum h will be with our maximum width. So the maximum area will occur when our width is 12 over 4 plus pi and our h is 6 over 4 plus pi. They'll both be in units of meters because meters is what we started with for our perimeter. All right, hope you've got a sense of how quadratics work, what their shape is, and this idea of the vertex, and that being where maximum and minimum are located. And remember, you just have to remember that the horizontal location for maximum or minimum, the horizontal location for vertex, is going to occur at negative b over 2a when we've got it in that standard form of ax squared plus bx plus c. As long as you remember negative b over 2a, you can just plug it in anytime that you need to find what the vertical location going along for that vertex is. All right, we'll see you at Educator.com later. Bye.